Section 3.2, our objective today is I can state and apply postulates and theorems about parallel lines. As a point of notation, from now on, if we see two lines with arrows on the line, that is notation to tell us that those lines are parallel. So we would say line A and line B are parallel lines because of the notation, okay? And we're going to look at angle 1, 3, 2, and 4, okay? So remember from section 3.1, angle 1 and angle 2 would be what we call corresponding angles. Angle 3 and angle 2 would be what we call alternate interior angles, and angle 3 and angle 4 would be same side interior angles. And so our theorems today deal with those specific types of angles. So the first theorem says if two parallel lines are cut by a transversal. Okay, so in our picture, C would be the transversal. Then corresponding angles are congruent. Okay, so it says if A is parallel to B, then angle 1 has to be congruent to angle 2. Okay, because angle 1 and angle 2 are corresponding angles. When you use this theorem, or any of the theorems that we're learning today, you cannot just say corresponding angles are congruent, because not all corresponding angles are congruent. Only those formed by parallel lines. So you must state the part about parallel lines. Okay? So make sure that you include that part when you're using these theorems as a reason. Right? So in our picture, by this theorem, angle 1 has to be congruent to angle 2. Okay? Our second theorem says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, so in other words, if A is parallel to B, then we can say that angle 3 is congruent to angle 2, because angle 3 and angle 2 are examples of alternate interior angles in this picture. And you can see that that makes sense because by the vertical angle theorem, angle 1 is congruent to angle 3. And if angle 1 is congruent to angle 2, then angle 3 must also be congruent to angle 2 by substitution. Okay? And then our third theorem says if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Okay, So going back to our picture up here, angle 3 and angle 4 are same side interior angles. And so this theorem says if A is parallel to B, then angle 3 and angle 4 are supplementary. Meaning, remember that they add up to 180 degrees. Okay? And our final theorem says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one also. Okay, so here we have line J, and it's parallel to line K. Okay, and we have line L that's perpendicular to line J. Then L must also be perpendicular to K. So it says if J is parallel to K and L is perpendicular to J, then L must be perpendicular to K also, right? Okay, so let's look at some application of these theorems. So examples. Right, so I have line J and line K, and they are parallel to each other. And I have transversal A, which is perpendicular to J, and transversal B. Okay, and so I have angle 1, 2, 3, 4, 5, 6, 7, 8. Okay, so in terms of this picture, what allows me to say that angle 3 is congruent to angle 7? Okay, well, angle 3 and angle 7 are this angle and this angle, and they are corresponding angles. And so the reason that we would give, for those being congruent, if two parallel lines cut by trans, then corresponding angles congruent. Okay? Number 2, how do we know that line A is perpendicular to line K? Right, well, line A is perpendicular to line K because, I'm sorry, I guess that should be a K right here. Sorry about that. Okay. Because of the theorem, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other also. Okay? Number 3, how do we know that measure of angle 6 plus measure of angle 7 equals 180 degrees? Okay? Well, looking at our picture, angle 6 and angle 7 are right there. Right? And what kind of angles are those? Those are same side interior angles formed by two parallel lines and a transversal. And so the theorem says if two parallel lines cut by a trans, then excuse me, same side interior angles are supplementary. All right, then number 4, how do we know that angle 6 is congruent to angle 8? Okay, angle 6 is congruent to angle 8 because, well, what kind of angles are those? Angle 6 and angle 8 are right there, so those are alternate interior angles formed by parallel lines and a transversal. So if two parallel lines cut by trans, then alternate interior angles are congruent. So that's the application of the theorem. Okay? How do we know that angle 4 is congruent to angle 6? Well, let's find angle 4 and angle 6. So angle 4 is right here. Angle 6 is right there. What kind of angles are those? Those are vertical angles. And so we know those are congruent by the vertical angle theorem. So we can say vertical angles congruent. All right. Now let's look at some problems where we actually want to find the measure of something. So I have 4 lines. This line is parallel to this line. Notice that it has 2 arrows on it. And then I have this line and this line. And this line is parallel to that line. Okay? And then I have angle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so number 1, if measure of angle 2 equals 80 degrees, then measure of angle 6 equals what? And measure of angle 7 equals what? Okay, well, let's find angle 2. So angle 2 is right here. It is formed by this line and this line. And then angle 6 is formed by this line and this line. So we have our transversal is the vertical one, and the 2 horizontal ones are the parallel ones. Then angle 2 and angle 6 are what kind of angles? They are corresponding angles. So 2 parallel lines cut by a transversal, then corresponding angles are congruent. So angle 6 must be 80 degrees. Then angle 7. Angle 7 is right here. So if we know angle 6 is 80 degrees, what does angle 7 have to be? Well, angle 6 and angle 7 are a linear pair that form a straight line, and so they have to add up to 180. So if angle 6 is 80 degrees, that means angle 7 must be 100 degrees. Okay, so this was 80 and this was 100. All right, how about number 2? If measure of angle 9 equals 105, then measure of angle 10 has to equal what? and measure of angle 16 has to equal what? Okay, well, let's find angle 9. So angle 9 is right here, and it's formed by this line and this line. Then angle 10 is angle 9 and angle 10 are a linear pair. So if angle 9 is 105, then 180 minus 105 is 75. Okay? Then angle 16 is formed by this line and this line. And so the vertical line here would be our transversal. The two horizontal lines are parallel to each other. So angle 10 and angle 16 are alternate interior angles. So two parallel lines cut by a transversal, then alternate interior angles must be congruent. So angle 16 must be 75 degrees.